Hey, Aerospace Engineering 2 class. Hey, just wanted to pass on some information and notes. And, I was thinking of typing this, and A, I didn't feel like typing, and B, I didn't think you'd read it if I did. So I figure if I tack this on to the footage from our launch yesterday, that hopefully you'll watch this at the same time. So a couple different things come to mind. A bunch of you are graduates and moving on to other things, and so have some maybe words of wisdom or advice for you and how that ties into the launch that we did. So I got to spend some time with a friend of mine the other day. He used to work for Boeing as an engineer, and then later on as a recruiter, and then as a recruiter trainer. And so one of the things that he talked about is that to these big companies, the ones you're probably going to end up wanting to work for as an intern and then also as an employee eventually, are doing these called structured interviews and structured interview questions. You ought to Google that and find out what that's all about. But one of the things that a lot of these companies are going towards is having a set of questions that they are allowed to ask you, and they'd like to ask you other things, but in order to make it fair and even across all of the people that they interview, they have to ask the same questions. They don't necessarily get to the information they want to get to. So here's what I'm talking about. You need to move the conversation into the things that are your strengths. So they might ask you a question like, one of the ones he gave as an example was, name a time that you worked with a difficult employee or fellow employee, and how did you solve that problem? How did it work out? Well, you're not going to have necessarily the answer to that, right? Because if you haven't worked with other employees. But what you can do is you can say, well, I don't have experience necessarily as an employee, but I got to work on a project in my aerospace engineering class where we built a rocket and glider system. And do you see what you just did there? You took their question and started to move it to something that you did, your strength. And that's what this friend of mine talked about, moving the conversation to your strengths. So you would say, in this time that I worked with this aerospace engineering class, we were designing a glider and rocket system. There was one member of the team who was whatever, fill in the blank. And see, you'll answer their question, but then they're able to ask you, oh, well, tell us a little bit more about that glider rocket system. And you see now where you can take that and talk all about this great technology and stuff that you develop. Okay, so that's one thing. Structured interview questions and moving the conversation to where you want to go. Next is, how does this relate to the launch? I don't know if you realize the significance of what we all did in that class. And so think about this. You've done rockets, you've done gliders, maybe you haven't even done gliders. Maybe Seth has done gliders, in planes. But think about what you did. You used analysis tools for stable flight of a rocket, thanks to a lot of work by Jackson. But you all need to be able to get a grasp of what was done by every team member so that you can talk about it. It gives you something very interesting and complex and concrete that you can talk about in your interviews. Believe me how valuable that is. Nobody wants to hear about another 4.3 student who studies all the time and gets whatever grades. They want to hear about your project. They want to hear about what went wrong, what went right, what would you do differently next time. They want to hear all that real life stuff because that's what they're hiring you to do. So go into it and say, the thing that makes this really unique is that we had to use the tools we had about stable flight of a rocket, which, as you know, means that we have to put the center of mass above the center of pressure. But in our application, our center of pressure was really determined by this glider, and the glider had to be positioned above the parachute system. Think about, at the end, what that monstrosity looked like. It had our center of mass being moved way up front by that one funny 1-inch tube proboscis, right? That moved all that lead way up high. And we did that to get it to match the model for stable flight. And we had stable flight. That's what's so amazing about this, is that we really did have stable flight. Now, we didn't have a stable flight for the glider. That was a much more complicated system to analyze, and we didn't really have the tools available to do that. We knew that we had to have its center of mass ahead of its center of pressure. We did that, but the one thing we didn't have is what speed is required in order to achieve that stable flight. And chances are it was much higher than just dropping from a few hundred feet. We needed to reach a pretty good speed to be able to get that to happen. Also, with no lifting airfoil on that wing. Now remember why we did that. Talk about that in your interview. We couldn't add a lifting airfoil because if we did that, we would get an unusual sideways force on our fin, the glider, as it was launching. So we had to go with a neutral fin design. And so remember all those things that we did and why. Where did the parachute go? Do you remember we had all these different concepts for a parachute? It was going to go up at the top. It was going to go in the bottom. Now, do you remember why or what was the challenge in putting it down low? Right? Because then it moved the glider up a little higher. And when it moved the glider up higher, what did that do to us? It moved our center of pressure higher, which means our center of mass had to be moved higher. And then what happens if you try to compensate for your center of mass by just adding a lot of mass? Right? Remember what the problem is there? Now your entire rocket weighs too much, and we don't have a motor that can get it to stable velocity before it leaves the launch rail. And remember that discussion, that the launch rail had to get longer and longer and longer based on the total mass. Now you were able to do something fairly unique. Instead of just throwing mass at it, you threw mass times distance. And that is why we had that big, long nose cone on that thing with all the weight way up there, 30 inches away, is because, remember, it's mass times velocity, or mass times distance to get us the turning moment basically at the top for stable. And so instead of throwing just mass, if you do mass times distance, you're able to get stability without adding as much mass. And that enabled us to find a motor that could get us to 40 miles an hour before we left the launch rail. So I want you to have all of those things in your mind of how and why. Do not just sit there in an interview and they ask you, name one interesting thing that you worked on as a project. I think that you can use this project all the way through college. This is the university level project that we worked on. This is more like a mini senior project. Don't miss the significance of it. Because really, the problems that we encounter there and the solutions and those kind of things are the things they want to hear about. And if they ask you, hey, what's a project you worked on? You're like, we made a rocket glider system. It was cool. Seth came in and did a lot of the work on the glider, and I just kind of sat there not knowing what's going on. No, talk about it. Talk about that Jackson was an important part of the team doing all the analysis. Talk about that we were in a remote situation and that we still had students doing analysis. We had students making composite spars. We had other students that were gluing things together and making pin pullers and putting together the parachute and analyzing the motor. That it was a team effort. That's what they want to hear about. They don't want to hear about that you were the Lone Ranger and you did everything. They don't want to hire Lone Rangers. You got to work on a team. So talk about the team. You don't have to say that you were the weakest member or something like that. I don't think there were any, so you don't have to worry about that. But again, talk to your strengths and use these kind of projects and activities as an excuse to be able to share all those things. All right, you're going to have more of these in your university days. You're going to have more of these if you're still at Oaks next year for another year. We're going to have more of these kind of projects. But I want to take a minute and teach you how to pull these projects apart and use them to your advantage. You are a great group of students, and it has been my privilege to be able to work with you this year, and I'm excited to hear about where you go in the future. Yes, I want to hear about where you go in the future. I want you to come back and visit. I want you to provide encouragement and hope to those other students that are coming behind you. And you are going to have really tough classes, and you're going to have tough years. And remember back to doing weird, impossible things, and with enough work and enough team, you were able to have successful launches. So hang in there, and I'll see you down the road. Here's pre-launch, last-minute surgery on holding the servo in.
Three, two, one, ignition!
Holy smokes, it worked! Oh my gosh, it worked! No parachute, lawn dart.
Oh god. What the?
Parachute, nice.
4, 3, 2, 1, launch! Alright, glad it's working.